On a frozen wild space planet called Rothana, there is a creature with 10 legs, a low center of gravity, a squatting stance it uses to brace against gale-force winter winds, and absolutely no idea it became one of the most recognizable war machines in the Star Wars universe. Its name is the Arctic horny whelmer. That is its actual canonical name, and we are using it without apology. The Arctic horny whelmer is native to Rothana's Arctic regions, a world of icy cliffs, mineral-rich soil, and violent cold-season storms. Being bulky and slow, it hunts in packs, wearing prey down through persistence rather than speed. Its low center of gravity lets it stay upright in conditions that would knock over a taller animal. It can scale cliff faces. According to Star Wars Complete Vehicles, the 2018 Disney Canon reference book, its sturdy form and peculiar squatting stance inspired the design of the all-terrain tactical enforcer walker, built with multiple qualities drawn from the creature. The connection was first documented in Star Wars Attack of the Clones' Incredible Cross-Sections, written by Curtis Saxton in 2002. It survived the Disney Canon reset and was confirmed again 16 years later. Whatever else changed when Lucasfilm restructured the expanded universe, the whelmer stayed. That's the ATTE, the Republic's low-slung, six-legged tank. Manufactured by Rothana Heavy Engineering, a subsidiary of Kuat Drive Yards operating on the same frozen planet as the whelmer, which apparently looked at the animal living outside its factory and said, "Yes, that." That method has a real name. It's called biomimicry, and Boston Dynamics uses it too. The honest version of the whelmer story is more interesting than the clean one, because the engineers didn't just copy the animal, they studied it and made deliberate choices about what to keep. The whelmer has 10 legs. The ATTE has 6. The engineers extracted the structural principle: low center of gravity, articulated stance, load distributed across multiple legs, then optimized it. 6 legs is enough for stability when the gait is managed correctly. With alternating tripod movement, 3 legs remain on the ground simultaneously, forming a permanent, stable base. The whelmer's natural locomotion demonstrated why that mattered in Arctic terrain. The ATTE's engineers took the lesson and chose the mechanically efficient leg count rather than the biological one. What the ATTE inherited from the creature is explicitly documented in Complete Vehicles. The design captured the whelmer's ability to withstand strong winds when crossing icy cliffs, its squat profile, and its sturdy form. The ATTE's 2 armored body halves connect through a flexible concertina section that also houses the power generators, an articulated joint that mirrors the load-distributing flexibility of a heavily jointed animal moving across broken ground. Each leg has triple-jointed hydraulic limbs. The whole sits close to the ground, keeping the center of mass low, which is why the ATTE can hold its footing on inclines where the taller AT-AT gets toppled by a tow cable. What the ATTE added beyond the biological blueprint? Magnetic feet. Terrain sensors and tractor-filled generators in the footpads allow the walker to magnetize its legs and hang upside down from metal surfaces. No canon source attributes magnetic grip to the actual whelmer. The creature climbed cliffs through biological means. The engineers looked at the animal's cliff-climbing capability, identified the structural principle, and designed an upgrade for a machine that might need to board a starship in vacuum. During the Battle of Deveron, Anakin Skywalker deployed 2 ATTEs onto the hull of an enemy Munificent-class star frigate while it was in deep space, walking upright on a pressurized metal surface. The whelmer can't do that. The whelmer inspired the engineers, who figured out how. The ATTE entered service at the First Battle of Geonosis in 22 BBY, reaching 60 kilometers per hour and carrying 20 clone troopers. Before the military contract, the design served commercial purposes. The ATTE traces its history to patrol work for mining operations before Rothana Heavy Engineering adapted it for the Grand Army of the Republic. A biomimetic design that worked in civilian extraction work turned out to work equally well in warfare. The separatist battle droid army nicknamed it 6 Legs. That was how distinctive the silhouette was. In 1997, a natural scientist named Janine M. Benyus published Biomimicry, Innovation Inspired by Nature. Her definition? A new science that studies nature's models and then imitates or takes inspiration from these designs and processes. The central argument was that nature had been engineering solutions for 3.8 billion years of selection pressure, and human designers were ignoring an enormous body of proven work. Her book formalized what had been scattered intuition into a named discipline with a methodology. Velcro demonstrates how old the underlying instinct actually is. Swiss engineer Georges de Mistral invented it in 1941, after examining under a microscope how burr seeds gripped his clothing. Tiny hooks catching loops at the fiber level. He didn't invent a new fastening mechanism. He copied one that had been refined by natural selection for millennia. Lotus leaves use microscopic surface bumps to repel water, and that structure now appears in self-cleaning architectural coatings. Shark skin geometry informs swimsuit design. In each case, identify what the biology solved, extract the structural principle, build an engineered analog. Rothana Heavy Engineering did this on Rothana. Real roboticists arrived at the identical approach on Earth, independently, a long time after a galaxy far, far away had already codified it. The Big Dog robot was created in 2005 by Boston Dynamics, with DARPA funding and hardware contributions from the Harvard University Concorde Field Station. It weighs 109 kilograms, roughly the size of a small mule, which isn't a coincidence in framing. DARPA's own program description called it a robotic pack mule, intended to carry equipment for soldiers across terrain too rough for conventional vehicles. The engineering rationale is stated plainly in the technical paper authored by Mark Raybert and his team at Boston Dynamics. Less than half the Earth's landmass is accessible to existing wheeled and tracked vehicles, but people and animals using their legs can go almost anywhere. Our mission at Boston Dynamics is to develop a new breed of rough terrain robots that capture the mobility, autonomy, and speed of living creatures. That sentence, capture the mobility, autonomy, and speed of living creatures, is biomimicry as a design brief. The methodology is identical to what Rothana Heavy Engineering used when it looked at the whelmer's low center of gravity and decided that was the shape a Republic tank should take. Big Dog's balance system works the way animals do, constantly adjusting posture in response to terrain rather than relying on static support. Inertial sensors measure body attitude and acceleration. Force sensors in each leg detect ground contact. The onboard computer integrates this data in real time to distribute load across all four legs, lean into slopes, and catch itself when a foot slips. It can run at 5 miles per hour, carry 340 pounds on flat ground, climb a 35-degree incline, and navigate mud, snow, sand, and loose rock. Its longest documented continuous operation was a 10-kilometer hike lasting 2.5 hours. Its power supply is a water-cooled, 2-stroke internal combustion engine producing 17 horsepower, driving a hydraulic pump that powers 16 leg actuators. That engine detail matters. Keep it in mind. In 2014, the militarized successor to Big Dog, the LS-3, known as Alpha Dog, participated in Marine Corps field exercises. It could carry 400 pounds, walk 20 miles in a single stretch, and follow a human leader using LiDAR without constant operator input. The engineering was substantially more capable than the original Big Dog in almost every relevant metric. The Marines shelved it in December 2015. The reason? Too loud. The combustion engine that gave LS-3 its carrying capacity produced noise audible from hundreds of meters away. The Marine Corps confirmed that LS-3 was already about 20 times quieter than the original Big Dog. It still wasn't quiet enough. The same engine that made the machine operationally useful made it operationally useless in any environment where acoustic concealment mattered, which is most combat environments. This is where biomimicry breaks down at scale. A mule generates carrying power through biological muscle, a chemical process that is nearly silent. When engineers tried to replicate load-carrying capacity mechanically, they needed combustion to produce enough power. The combustion engine is loud. The muscle isn't. At 109 kilograms, carrying 340 pounds, the engineering solution and the biological solution diverge precisely because biological muscle combines power output and acoustic silence in a way no combustion engine does. The Big Dog technical paper, under Future Plans, listed quieter operation as a stated goal, noting that Big Dog was a noisy robot. They knew. They just hadn't solved it. The electric Spot robot, released commercially in 2020, is Big Dog's direct successor. Its electric actuators are substantially quieter than the combustion hydraulics of Big Dog. Spot carries 45 pounds rather than 400. It currently works at BP oil facilities, construction site surveys, and tunnel inspections, doing real jobs in real industrial environments. The biomimetic principle scaled commercially when the power source changed from combustion to electric. What didn't scale was the load capacity. That trade-off is still live. Run the parallel catalog across Star Wars walkers and real-world robots, and the fiction-to-reality connections become specific enough to check. The ATTE has a confirmed in-universe creature origin, 2 separate canon sources spanning 16 years. Real hexapod robotics arrived at the same architecture from a completely different direction. R-Hex, robotic hexapod, was developed between 1999 and 2001, DARPA-funded, built primarily at the University of Pennsylvania's COD Lab under researcher D.E. Koticek. Its foundational paper describes the design as inspired by biomechanics insights into arthropod locomotion. The specific animal? Cockroach. Robert Full at UC Berkeley had spent years studying how cockroaches maintain speed and stability across rough terrain, and that research fed directly into R-Hex's gait. The team ran comparison experiments on terrain specifically scaled to cockroach proportions to evaluate R-Hex's performance against its biological source. R-Hex uses 6 C-shaped compliant legs, 1 actuator per leg, and an alternating tripod gait. It traverses rocks, mud, sand, snow, and railroad tracks. It climbs stairs. Star Wars built the ATTE by studying a multi-legged animal native to Arctic terrain. Roboticists built R-Hex by studying a multi-legged insect optimized for rough terrain. Both machines use 6 legs and an alternating tripod gait. Neither development team knew the other existed. The ATAT is the harder case. There is no named in-universe creature ancestor for the ATAT, the way there is for the ATTE. What exists is the production history. ILM animator Phil Tippett studied elephant locomotion, filming reference points on an elephant's body to capture how a heavy quadruped shifts weight across 4 legs, and used that footage to animate the ATAT's walk. The proportions drew from Paraceratherium, a prehistoric mammal related to rhinoceroses, standing approximately 5.5 meters at the shoulder, among the largest land mammals ever documented. Animal references embedded in production design, not in universe lore. Its real-world engineering parallel is Spot, not because Spot was designed to look like an ATAT, but because the underlying biomechanical problem is identical: 4-legged dynamic stability with a high center of mass. Both systems maintain balance by continuously adjusting rather than relying on static support. Both fail the same way when terrain becomes adversarial. The AT-AT goes down to a tow cable wrapped around its legs at the Battle of Hoth. The original Big Dog went down to a gas engine the Marines couldn't use quietly. The AT-ST needs the least explanation. Its canonical nickname is Chicken Walker, not a fan description, canon. The 2-legged gait, the forward inclined posture, the small forward-facing cockpit head. No documented in-universe creature origin exists for the AT-ST, but the nickname already tells you the bird it resembles. Atlas is its structural counterpart. Boston Dynamics' bipedal humanoid robot, originally built for the DARPA Robotics Challenge, uses dynamic balance. It's continuously falling forward and catching itself, modeled on human center of mass dynamics through the linear inverted pendulum model. At the 2015 DARPA Robotics Challenge finals, teams running Atlas robots recorded 14 falls in official runs across a single day. The ATST makes the same admission at the Battle of Endor. A pair of logs on ropes ends the walker's operational life. Both systems fail in the same specific way. Unexpected ground state change defeats a balance system built for predictable terrain. In 1995, a Finnish company called Plus Tech Oy, the research and development unit of forestry equipment manufacturer Timberjack, built a prototype six-legged walking harvester. The rationale was direct. Wheeled forestry machinery compacts soil and struggles on steep slopes. A walking machine distributes weight across more contact points at each step, reducing ground pressure and allowing stable operation on terrain where a wheeled vehicle would sink or tip. The Finnish Forestry Museum described the concept as suitable for steep slopes without tipping risk, gentler on the forest floor. 2 prototypes were built. Timberjack was acquired by John Deere in 2000 and eventually fully absorbed. The walking harvester never reached commercial production. But the machine existed. It operated in a real Finnish forest, doing practical forestry work on 6 legs, for the same structural reasons that produced RHEX and the ATTE and every hexapod robot that came after. When you need to move a heavy load across uneven terrain without wheels, legs solve specific problems that wheels can't, and 6 of them is a geometrically stable choice. Nobody called it science fiction. Nobody called it biomimicry either. They called it a forestry machine, and it worked. And then the company got bought, and it sits now as proof that the Walker through biomimicry pipeline already produced a functioning real-world result before Boston Dynamics built Big Dog, and before most Star Wars fans had heard of the Arctic horny whelmer. So, did Star Wars get the engineering right, or did it get lucky? The ATTE specifically has a documented origin in a real creature, and that origin survived a complete canon reset. Rothana Heavy Engineering's engineers didn't copy the whelmer exactly. The whelmer has 10 legs, the ATTE has 6. They extracted the structural principles and optimized them. That's textbook biomimetic practice. Take what evolution solved, make deliberate improvements, build something that works in conditions the biological original never encountered. DARPA used the phrase robotic pack mule to describe precisely what they wanted Big Dog to be. Boston Dynamics wrote in their own technical paper that the mission was to capture the mobility, autonomy, and speed of living creatures. Janine Benyus published the formal framework for this approach in 1997. RHEX, Big Dog, Spot, and the Plus Tech walking harvester all arrived at legs from animals as a legitimate engineering method, independently, across different decades and institutions. None of them working from a Star Wars screenplay. Where Star Wars may be working on credit rather than proof is the scale. The AT-AT stands 22 meters tall. At that mass, structural load increases faster than structural strength, a relationship Galileo identified and engineers still have no clean biological solution to, because no animal on Earth approaches that size on legs that thin. Big Dog, at 109 kilograms, already required a combustion engine loud enough to end its military career. Scale that power requirement up to move a 22-meter walker, and noise is the least of the constraints. The biomimetic method produced Spot and RHEX and a walking machine in a Finnish forest. It produced the ATTE. Whether it can produce something the size of a building, at a weight requiring power systems biology has never had to evolve, that question went unanswered when the Marines shelved LS-3, and Star Wars doesn't have to answer it, because the galaxy far, far away has power sources we don't. The Arctic horny whelmer has 10 legs, a squatting stance, and no awareness that engineers on a frozen wild space planet studied it carefully enough to build a war machine. Boston Dynamics had a DARPA contract and a mission to copy how animals walk. Both of them ended up in the same place, separated by a galaxy and a few decades. Whether that means biomimicry reliably produces the right answer, or whether nature's solutions are simply so well optimized that any engineer copying them converges on similar results, leave that one in the comments. Subscribe for more stories like this.